Okay, hello, this is Dr. Hanaa Assil, and today we're talking about a topic in physics, which is mainly for the grade 8 checkpoint or the lower secondary checkpoint. And today we're talking about forces. So, first of all, we probably know that force is a push or a pull. So, when we push on something or pull on something, we are exerting a force. This may result in change in speed of the object, making it faster, or direction of the object, or shape of the object, whether we elongate it or we squash it. So the force is usually measured using a force meter or a spring balance, and we already should know that the unit of force is newtons. Now, when we have a force on um, a spring, this causes an extension in the spring. The extension is the increase in length of the spring. So the heavier the object that I put, the larger the extension on the spring. And this means that what we have on the spring is actually a force. Now, are we measuring the mass or the weight when we do that? Actually, when we put an object on a spring balance, we're measuring its weight, not its mass, because mass is the amount of substance in an object, and the mass is not affected by place where it is, or it is not affected by gravity. While weight is actually the pull of gravity on a force, so the weight is regarded as a force. It will change from one place to another depending on the amount of gravity, because the amount of gravity on the moon, for example, is less than that on Earth, so the object will have a different weight on the moon, but not a different mass. The unit of mass is kilogram and the unit of weight is Newton, since it is a force. The types of forces. So the first type of force that we talked about was gravitational force, and gravitational force is the force of gravity that attracts objects to the Earth. This is the force that results in the weight of an object. Now, magnetic force is the force between magnets, and we already know that magnets have a pole that points to the north, or an end that points to the north and an end that points to the south. And there is attraction between poles that are different, so the north will attract the south and the south will attract the north, but there is repulsion between the similar poles or the like poles. Or there is also an attraction between the magnets and a magnetic material like iron or steel or nickel or cobalt also. Any of these will be attracted to a magnet, so all of this is due to magnetic force. Electrostatic force is the force due to charged objects, things that are positive and negative. So there is attraction between charges that are opposite. So a positively charged object will attract a negatively charged one. And there is repulsion between similarly charged objects. So positive and positive will repel, negative and negative will repel. So all of that is electrostatic force. Now, air resistance is also a force, and this acts on the objects that are moving through the air. So, a person that is jumping out of an airplane will have two different forces acting on it. There is gravity that is trying to pull him down, and there is air resistance that is trying to push him up. Upthrust is a similar force, but in water. So the water tries to push everything up, so that is called upthrust. A boat will float on the water because the upthrust is more than its weight. If its weight becomes too much, then it will start to sink. Tension is the force in objects that are being pulled. So when we pull on a string, the string develops force of tension. Centripetal force is the force that keeps the object moving in a circle. So as we go round and round and round, the centripetal force tries to push everything out of the circle. So that is a centripetal force. Friction is also a force. It acts opposite to an object that is moving. So if an object is moving in one way, then there is friction trying to push it in the opposite way, so it acts opposing to the movement. Now, we usually need to reduce friction. In order to reduce friction, we do that by either putting a layer of oil between two surfaces or using wheels like those that are on skateboards. Okay, now forces that are horizontal can either be opposing to each other or in the same direction. Now, if we have an object that is sitting there, stationary, and there are two opposing forces in opposite directions. Now, if they are equal, that means that the object will have no net force on it. So there is a zero net force on it. And that means that this object, if it is stationary or if it is just sitting there, it will remain stationary. It will not move. If I'm pulling the box from both ends with equal force, it will not move. But if this is an object that is already moving, so if we're already moving at a constant speed, it will continue at a constant speed if the two opposing forces are the same. Okay? What if they are not the same? What if one of them is larger than the other? Then the object will start to move towards the side with the higher force, and the net force or the overall force is the difference between the two forces. If both forces are in one direction, the same direction, then the object will move in that direction and the net force is a total of the two forces. Okay, what if the object is on a ramp? You know that a ramp is a path that is slanted. Now, if this object is trying to go down, that means there is a force applied on it, allowing it to go down. But as it goes down, there is friction between the object and the surface of the ramp, and the friction is in opposing direction to the applied force. There is also a force of gravity due to the weight of the object. So we have actually three main forces acting on that object, and whichever one is higher or lower will determine how fast this object is going down the ramp. One of the main things about the ramp is the slope of the ramp, whether it is very steep like the one on the right or it is less steep like the one on the left. And in that case, the movement of the object depends on how steep the ramp is. So it depends on the gradient of the ramp. It depends on the weight of the object, whether this is a heavy object or a light object. And it also depends on the surface of the object, whether the surface is smooth or rough. Okay, another force is air resistance. Air resistance is something that is experienced by someone, for example, that is jumping with a parachute. Now, the air resistance, how much it is or how high it is, depends on the speed of the air current, the speed of the object that is moving through the air, and the area of the object in contact with air. So if the person's parachute is much larger, then there will be more air resistance and he will come down slowly. Okay, this was a brief explanation of this chapter. Please listen to the following video.